Hi everyone, it's Scott from Maths Logos, and in this lesson we're going to look at how we can prime factorise numbers, and we're going to look at quite a few different ways that this question can be asked. Okay, let's look at our first example. Write as a product of its prime factors 6 and then 18. Let's quickly explain what it means by writing something as a product of its prime factors. The word product in this case means to multiply, and a prime number is a number that has only two factors, 1 and itself. So for example, 2 is a prime number because it only has two factors, 1 and itself. And what we need to know is that every whole number can be written as a product of its prime factors. Let's take 6 as our example. We can write 6 as 2 multiplied by 3. And because both 2 and 3 are prime numbers and we're multiplying them together, we've written 6 as a product of its prime factors. Our next example is 18. And so we want to rewrite it as a product of its prime factors. Now there are different ways we can start this question. One way is to write 18 as 2 multiplied by 9. And then what we can do is we can check to see which of those are prime. Well, 2 is a prime number, so I'm going to leave that, but 9 is not, so I need to split it further. So what I'll then do is I'll keep my 2, and I'll rewrite 9 as 3 multiplied by 3. And in this case, 2 and 3 are both prime numbers, so I've now written it as a product of its prime factors. What I can do though is I can tidy it up and write it in what we call index form. An index form is where we write 3 multiplied by 3 as 3 squared. The other thing we want to check is that we've written it in ascending order, which is where we start with our smallest prime factor first. So in this case, I've done that because 2 is smaller than 3. Pause the video and give these two questions a go. So 14 we would write as 2 multiplied by 7. And then we want to do a quick check. Those are both prime numbers, so that's okay. I don't need to simplify it any further. 20, there's different ways we could do this, but let's start with 2 multiplied by 10. And 2 is a prime number, so I can't go any further, but 10 is not, so I need to split that to 2 multiplied by 5. My next line would be 2 multiplied by 2 multiplied by 5. So I've just changed the 10 to 2 multiplied by 5. And 2 and 5 are prime numbers, so I can't go any further. I'll then just simply write it in index form. 2 multiplied by 2 is 2 squared multiplied by 5. Okay, let's look at our next example. Write as a product of its prime factors 36 and then 120. So we can start this in different ways. I'm going to start by rewriting 36 as 6 multiplied by 6. And 6 is not a prime number, so I need to split that further. I'll split 6 into 2 multiplied by 3, and I'll split this 6 into 2 multiplied by 3. And we have two principles in mathematics. One is called commutativity, and the other is called associativity. And that allows us to swap the order and regroup numbers. So I'm going to rewrite my second line as 2 multiplied by 2, multiplied by 3, multiplied by 3. And I want to write it in index form. I'll do 2 multiplied by 2 to give me 2 squared, and 3 multiplied by 3 to give me 3 squared. And I can check that it's in ascending order, so I start with my prime factor of 2, and then I have my prime factors of 3. So that's fine. Our second example is 120. Let's rewrite 120 as 12 multiplied by 10. 12 and 10 are not prime numbers, so I need to continue to simplify. Let's rewrite 12 as 3 multiplied by 4. And we'll rewrite 10 as 2 multiplied by 5. 3, 2, and 5 are prime numbers, but 4 is not. So I need to rewrite 4 as 2 multiplied by 2. So I'm just going to rewrite 4. And then write down my 2 and my 5 like I had before. Okay. Then what I can do is I can turn it into index form. I'm going to collect together my lowest prime number, which is 2. So I'll do 2 multiplied by 2 multiplied by 2 to give me 2 cubed. And then I'll multiply that by 3 and multiply that by 5. So it's in index form and it's in ascending order. Pause the video and give these two questions a go. All right, let's go through them. So 42 I can write as 2 multiplied by 21. And 2 is a prime number, but 21 is not. So I'll keep the 2. And 21 I can write as 3 multiplied by 7. And that's it, it's in index form. 160 I can write as 16 multiplied by 10. And I'm going to use the fact that I know that 16 is 2 to the power of 4 to make this a little bit quicker. So 16 is 2 to the power of 4, and 2 is a prime number, so that's okay. And then I'm going to multiply it by 10, which I can write as 2 multiplied by 5. 2 to the power of 4 multiplied by 2 is 2 to the power of 5 multiplied by 5. That's my answer. If you're enjoying the video so far, please subscribe to this channel. It really helps me out, it helps me to grow, so thank you for that. Our next example says, write as a product of its prime factors 360. So I'm going to rewrite 360 as 36 multiplied by 10. And neither 36 nor 10 are prime numbers, so I need to keep going. 36 I can write as 6 multiplied by 6. And 10 I can write as 2 multiplied by 5. Both 2 and 5 are prime numbers, so I don't need to simplify them any further, but 6 is not, so I need to keep going. I can rewrite 6 as 2 multiplied by 3, and I have another one, so I need to do that again. And then I need to remember to write down my prime factors from before, like this. So 2 and 3 and 5 are all prime numbers, so I can now collect it together. Let's count up how many 2's we've got. We've got 1, 2, 3, so I can write that as 2 cubed. And I've got 1, 2, 3, so I can write that as 3 squared, and I've got 1, 5. So it's in index form and it's in ascending order. Our next one's 5,000, and this might seem like it'll take a really long time to do, but actually there's a quicker way to do it, and I'm going to show you that. Let's rewrite 5,000 as 5 multiplied by 1,000. And 5 is a prime number, but 1,000 is not. So what I can do is I can rewrite 1,000 as 10 to the power of 3. In other words, 10 multiplied by 10 multiplied by 10. And then I'm going to use the fact that I know that 10 is 2 multiplied by 5, and I'm raising that to the power of 3. I've just rewritten my 10 as 2 times 5. You might then think, well, what is 2 multiplied by 5 all to the power of 3? And it's just 2 multiplied by 5, multiplied by 2 multiplied by 5, multiplied by 2 multiplied by 5, like that. But a quicker way to get to our answer is just to apply this power to both the 2 and to the 5. So 2 times 5 to the power of 3 is 2 cubed multiplied by 5 cubed. I can then use that back in my original example. So I've got 5 multiplied by 2 cubed multiplied by 5 cubed. I want to write it in ascending order, so let's start with the 2 cubed term. And then I have 5 multiplied by 5 cubed, which is 5 to the power of 4. And that's my answer. Pause the video and give these two questions a go. Let's go through these. Write as a product of its prime factors 490. So I can write 490 as 49 multiplied by 10. And 49 is 7 squared, or 7 multiplied by 7. And 10 is 2 multiplied by 5. So this is already in index form. I just need to write it in ascending order. So I'll put it as 2 multiplied by 5 multiplied by 7 squared. Then we have 80,000. So I can write this as 8 multiplied by 10,000. And I can write 8 as 2 cubed. And I can write 10,000 as 10 to the power of 4. I then rewrite 10 as 2 multiplied by 5, all to the power of 4. And I apply this power to both the 2 and to the 5. My next line will look like this: 2 cubed multiplied by 2 to the power of 4 multiplied by 5 to the power of 4. 2 cubed multiplied by 2 to the power of 4 is 2 to the power of 7. And then I need to remember to write my 5 to the power of 4. That's my answer. If you're using our lesson booklets, you can now pause the video and complete exercises 1, 2, and 3, or alternatively, you can finish watching the video and do your exercises at the end. Our next example involves using the prime factorized versions of two numbers to find the highest common factor. So let's have a look at this one. Given that 120 is 2 cubed multiplied by 3 multiplied by 5, and 300 is 2 squared multiplied by 3 multiplied by 5 squared, find the highest common factor of 120 and 300. So to find the highest common factor, we want to write down all the factors that they have in common. Let's have a look at this in turn. Start by looking at our 2's. So 120 has 2 cubed and 300 has 2 squared. So what do they have in common? Well, they have 2 squared in common. We'll then look at the 3's. So 120 has one prime factor of 3 and so does 300. So they have a prime factor of 3 in common. And then if we look at the 5's, well, 120 has 1 5 and 300 has 2 5's. So they have 1 5 in common. We can then actually work out what our highest common factor is. 2 squared is 4 multiplied by 3 multiplied by 5. 4 multiplied by 3 is 12 multiplied by 5. And 12 multiplied by 5 is 60. So their highest common factor is 60. Pause the video and give this question a go. All right, let's run through it. Given that 1008 is 2 to the power of 4 multiplied by 3 squared multiplied by 7, and 270 is 2 multiplied by 3 cubed multiplied by 5, find the highest common factor of those two numbers. Let's consider all the factors that they have in common. Let's look at our 2's to start with. This has 2 to the power of 4 and this has 2. So they only have 1, 2 in common. We then look at our 3's. This has 3 squared and this has 3 cubed. They have 3 squared in common. And then they don't have anything else in common after that. So that's my highest common factor, which is 2 multiplied by 9, which is 18. So in our next example, we're going to use the prime factorized versions of the numbers to find the lowest common multiple. Given that 600 is 2 cubed multiplied by 3 multiplied by 5 squared, and 630 is 2 multiplied by 3 squared multiplied by 5 multiplied by 7, find the lowest common multiple of 600 and 630. leave your answer in index form. The way I like to think of the lowest common multiple is that it's the highest common factor multiplied by any factors that are left over. Let's start by finding our highest common factor in the same way as we did before. So we'll consider our prime factors of 2. So they have 1, 2 in common. Then we'll consider our 3's. This has 1, 3. This has 2 3's, so they have 1 in common. And then we'll consider our 5's. So this has 2 5's and this has 1 5. So they have 1 5 in common. And they don't have anything else in common after that. Our lowest common multiple is equal to our highest common factor, so that's what we've already looked at, multiplied by anything that's left over. And what I mean by left over is if we've used up one factor of 2 here, and we've used up one factor of 2 here, then there are 2 2's left over, so to speak. So that's left over. When it came to our highest common factor for the 3's, we'd already used a 3 here, and we'd already used one of the 3's here, so there's 1 left over. And when it comes to the 5's, we've already used one of our 5's in both of our lists, so there's 1 5 left over. And then we also have this 7, which we can't forget about, which we didn't use in the highest common factor, so it's also left over. So this gives me this line. The lowest common multiple is the highest common factor multiplied by all of those factors which were left over. And I can then rewrite the highest common factor as 2 multiplied by 3 multiplied by 5. And I'll quickly rewrite what I have put here. And then I can collect together my prime factors that are the same. So I've got 2 multiplied by 2 squared to give me 2 cubed. And I've got 3 multiplied by 3 to give me 3 squared. And I've got 5 multiplied by 5 to give me 5 squared. And I also have this 7. Now that's going to be a very, very large number, but it says leave your answer in index form, so this is fine. Pause the video and give this question a go. Okay, let's go through it. Given that 90 is 2 multiplied by 3 squared multiplied by 5, and 84 is 2 squared multiplied by 3 multiplied by 7, find the lowest common multiple of 1984, leave your answer in index form. Let's start by finding the highest common factor of both of these numbers, and we'll look at what they have in common. So they've got 1, 2 in common. And when it comes to the 3's, this is 3 squared and this is 3, so they have 1, 3 in common. And they don't have anything else in common. So they don't have a factor of 5, both of them, nor do they have a factor of 7, both of them. My lowest common multiple is my highest common factor multiplied by whatever was left over. When it comes to our 2's, we'd already used up one of them, so there's 1 left over. When it came to our 3's, we'd already used up one of them, so there was 1 left over in the 90. And then we've got a 5 and a 7 left over as well that we didn't use in our highest common factor. We know our highest common factor is 2 multiplied by 3, so I'll just rewrite that and then multiply by all of these numbers. And then we want to write it in index form. So I've got 2 multiplied by 2, so that's 2 squared. I've got 3 multiplied by 3, so that's 3 squared, multiplied by 5 multiplied by 7. In our next example, we're going to look at how we can simplify fractions using our prime factorized versions. Given that 200 is 2 cubed multiplied by 5 squared, 620 is 2 squared multiplied by 5 multiplied by 31, simplify fully 200 over 620. I'm going to rewrite my numerator 200 as 2 cubed multiplied by 5 squared. And I'm going to rewrite my denominator as 2 squared multiplied by 5 multiplied by 31. And what I can do is I can simplify my 2's with my 2's, my 5's with my 5's, and so on. And to help us see that a little bit clearer, I'm going to rewrite this fraction as 2 cubed over 2 squared, multiplied by 5 squared over 5, multiplied by 1 over 31. I have to be careful there because there's no 31's on the numerator, and the 31 that I do have is on the denominator. And now what I can do is I can simplify each of these fractions. So 2 cubed divided by 2 squared, I'm going to divide through by 2 squared on the denominator and on the numerator. That leaves me with 2. It's 2 over 1. And then I can divide through by a 5 on the denominator and a 5 on the numerator. I can then rewrite these fractions so it's a little bit clearer. So this is 2 over 1 multiplied by 5 over 1 multiplied by 1 over 31. And when it comes to multiplying fractions, I multiply all of my numerators together. So 2 multiplied by 5 multiplied by 1, which is 10. And then 1 multiplied by 1 multiplied by 31, which is 31. That's my answer. Pause the video and give this question a go. Given that 360 is 2 cubed multiplied by 3 squared multiplied by 5, and 540 is 3 squared multiplied by 3 cubed multiplied by 5, simplify fully 360 over 540. Let's rewrite the numerator and the denominator of our fractions. So I'll rewrite the numerator as 2 cubed multiplied by 3 squared multiplied by 5. And I'll rewrite my denominator as 2 squared multiplied by 3 cubed multiplied by 5. And then I'll consider each of those numbers in turn. So let's look at 2 cubed over 2 squared, and 3 squared over 3 cubed, and then 5 over 5, which we know is going to be 1, but let's write it out like this. And then we'll look to simplify each of these fractions. So 2 cubed divided by 2 squared. Let's divide through by 2 squared on the denominator and 2 squared on the numerator. That would leave me with 2 left over. And here I want to divide through by the highest common factor. Well, that would be 3 squared. If I divide through by 3 squared on the numerator, that gives me 1. If I divide through by 3 squared on the denominator, that gives me 3. And then 5 divided by 5 is just going to be 1. So I'll rewrite my fraction so it's a little bit clearer. This fraction is 2 over 1 multiplied by 1 over 3. And then that would be 1, so I'm not going to write it. I'll go ahead and multiply my numerators. 2 multiplied by 1 is 2. 1 multiplied by 3 is 3. So that simplifies to 2/3. If you're using our lesson booklets, now complete exercise 4. Thank you very much for watching this video.